Archiving started.
All right, welcome to Women in Science and Engineering. Thank you for coming today. This is our monthly seminar. My name is Dr. Ashley Spring, and I teach biology here at the Melbourne campus. And my co-chair is Dr. Mary Rosanowski, our Associate Provost here at the Melbourne campus. Thank you for coming. Women in Science and Engineering is a program here at ESSC that is committed to the recruitment, retention, and advancement of underrepresented groups in science and engineering. WiSE is open to all students. We have monthly seminars like you are attending today with guest experts in their fields in science and engineering to share advice with you about how to get into their fields of your interests, ideas for your careers in STEM. Workshops on careers, resume building, and graduate school. You'll see on the flyers going around if you'd like to collect one. We have a workshop coming up on resume building and career options in STEM fields coming up on April 10th. Networking for future schools and employment, local excursions. We also have coming up on April 3rd a free of charge to you visit to UCF Research Showcase. So we will be leaving here from the Melbourne campus, heading over to Orlando to UCF to visit a large number of students presenting their research that they've done at UCF in poster presentations and getting an idea of some of the amazing research that happens right here in our state. Career mentoring and undergraduate research. If you are interested in any of these things, please contact either Dr. Rosanowski or myself, and also visit our website. Our website is www.easternflorida.edu/WISE, W-I-S-E. Today we're going to hear from Eileen Pirelli, who's a senior scientist at EBSCO and a recent addition to the math department here at the Melbourne campus. Our last seminar of the semester is on April 15th, which is Jody Palmer from the Oyster Restoration Coordination at the Brevard Zoo. There is a large research effort going on statewide focused on the Indian River Lagoon to improve our waterways. One way to do that is to release oysters to filter water and the natural effect to clean our waterways. That's coming up on April 15th. As I mentioned before, on April 3rd is our field trip to the UCF Undergraduate Research Showcase. The deadline to sign up for that is tomorrow. So if you are interested, please contact our Associate Provost, Dr. Mary Rosanowski, if you would like to sign up for that. On April 10th is your workshop on finding your career, which will also be held in this classroom from 3 o'clock to 5 o'clock. Without further ado, I would like to invite our guest speaker today, Eileen Pirelli. Thank you.
Thank you. Am I in the thing? Okay. Let me just practice here a second. Okay, we're good. Yeah, to be clear, I actually currently work here. I'm a math instructor, and I was trying to quit my last job, EBSCO. I worked there 17 years. I am still an employee of EBSCO. I currently work, quote, as needed. So in case they call me and say, something broke, come fix it. Otherwise, don't call me. I wrote a lot of computer code, so a lot of those programs live on without me and need maintenance. So let's see. So my first slide, I actually want to go to the web. I went to the Florida Tech Library, and the librarian showed me a stack about a half-inch thick papers of all the math disciplines. And I looked at it and I said, no, something's wrong here. You got to be kidding me. And I'm looking. I think it's the Library of Congress and some other places, such as the mathematics subject classification, will list all of the branches of mathematics in case you ever want to look for a journal article or look for a book. I was amazed at all the branches of math. I'm sure I know this much. There's this much out there. I know as much math as, coming up through the undergraduate and graduate years and then exploring on my own, working with people outside of the math department, such as biologists, chemists, meteorologists. So I've ventured into different areas of math. But let me just show you really quick this math classification guide that, let's see. Oh, we're not going to update Firefox. Come on. Let's see. So here is just a short list. You see these numbers on the left, 1, 3, 5, 6, 8. These are just all these branches of math. Can you see that? That exist. And again, I probably know this many. So I'm your one data point. For those of you who are in statistics, I'm one data point. Don't come away from this talk thinking this is the way all mathematicians live and work. I am one data point. So I'll give you my background on how I got here. So two of the areas that I'm very proficient in is numerical analysis and differential equations. After you get through your calculus series, you'll take a class called differential equations, which is applied calculus. So in calculus, you might be learning about derivatives and integrals, and those are basically nouns or verbs in a sentence. You put the sentence together in differential equations. And when you have differential equations is when you can start math modeling. So I'll take you through a couple of slides of diffie-Qs. Numerical analysis is a term I've used for years, but for many people, they'll hear the word computational mathematician, and it's really the same thing. It's taking mathematics from the pencil and the paper to the computer. Instead of solving, where's the intermediate algebra students in here? Solving system of equations where you plot points on a plane. You have two equations with an x and a y. Go to thousands of equations with thousands of x and y. So you're going from pencil and paper up to the computer to find the solutions to your system if you have one. Okay? Sorry, I'm Shift F5. I'm going to remember that. I don't use PowerPoint much, but this is a very simple description of going from mathematics on a pencil and paper to using a computer. So if you've taken basic physics, you may recognize what's called the distance and the velocity formulas. So the distance is I'm going to throw a ball, and it's going to go so far, and I'm going to throw it with some velocity out of my hand. At some point, that ball is going to hit the ground. And so we can track the projectile of that ball through time. So we go from a basic equation up to the left, and we can build a computer program. You can choose whatever language you want, Java, C, I think this is MATLAB code, or a version of it. I'm proficient in many computer languages, but that's it. I don't know French, I don't know Spanish. But what you'll find if you do start taking programming languages is they're all very similar. They all look alike, they all have numbers, they all have the plus sign. So if you do learn one language, you can probably learn another language pretty quickly, okay? So don't be afraid of that. So once we put our little equation, you can see the S formula here and the V formula here. So we can crank through this for different values of time. And in the end, we can build a plot. And I'm sorry this isn't the best plot, but if you look at the blue dot, that might be the plot of the equation S, okay? I stole this plot from some other work of mine, some of the work from my PhD. So again, going from simple pencil and paper, your physics class, to putting those equations onto a computer, and then hitting go and generating graphs of data. Okay, so this is a mathematical model, a computational mathematical model. Now, differential equations, as I mentioned, is really, to me, the heart and soul of mathematical modeling. Once you get through the drudgery of learning Calculus 1, and then you get to Calc 2 and say, gee, I should have paid attention more, right, in Calc 1. I'm one of those students. So once you get through calculus and you learn how to put together derivatives, you come up with differential equations. And when you do, you can model things. How many have seen this Tacoma Narrows film? Okay, I've seen this about 100 times. When I was a physics student in high school until probably 10 years ago, I watched this movie over and over. It's a bridge in Washington State that, I don't know, when was it, 1940? And they built it, and then the wind was blowing, and it started doing this. And I don't know how long it was, a year or so, that bridge finally fell. And so if you ever pick up a book on differential equations, you will see the mathematics of why this occurred, okay? So obviously engineers study differential equations because they want to make sure that doesn't happen again. This was on my bucket list. I got to go visit the new one about 10 years ago, and they have a museum on the other side that has the same movie of the old one. So if you ever, go to Google, or excuse me, go to YouTube and put Tacoma Narrows, and you'll see a man walking down the center of the bridge, and the bridge is doing this. Okay. Now, I don't know much about biology, and if I talk to a biologist, my eyes glaze over. Whenever they say DNA and RNA, that's about all I know about biology. But when a biologist starts talking about AIDS, I'm interested. I'm interested because years ago, I met a mathematician who worked at a place called Los Alamos, Mexico, which is where a lot of science is done. It's a federal lab. And he said, I was sitting around the table with all my mathematician friends figuring out how to predict how many AIDS patients there will be in 10 years. And I thought, why is this mathematician talking about biology? And as it turns out, mathematics is applied to biology. Math is a very interdisciplinary science. If I can talk to the biologist, because when he starts talking about the rate of change of infection, to me that means, oh, there's a derivative there, right? Something's changing with respect to time. So I don't know. T cells are growing. Again, I don't know biology, but when you start talking about rates of change, something coming into the population and leaving the population, my brain starts putting equations together. I don't know what he's talking about, but I can make a model from it, okay? So forgive me if I'm not going to discuss these terms. Maybe you. Here's a set of differential equations. And what you may see on the left are derivatives, and on the right are a bunch of other stuff. But this is one type of model that is built by putting together a mathematician and a biologist. And I think this, I thought I was looking for the one AIDS. Yeah, HIV. So again, when you take differential equations, you'll be able to set this model up, solve it, and then predict how many cases of infection you'll get over the next 10 years, okay? So math is applied in many different areas. So keep that in mind when you're going through chemistry and biology. Keep in mind, calculus will come in handy, believe me. This is another very simple math model applied to epidemiology. The Centers of Disease and Control, thank you, is in what, Atlanta? Yes. Anytime there's a flu outbreak, they've got mathematicians sitting there and they're saying, how many cases do we have today? How many cases do we have tomorrow? And what they're looking at is change. It's going up, it's going up, it's coming down, it's coming down. So I have all these people in the room. Nobody can come in and nobody can leave, and my son has the flu. Guess what's going to happen? You're going to get it. You guys are going to get it. So what we have is a population of who is susceptible. The change in susceptible people, ds by dt. There's a number of people who are going to get infected at some rate. And then there's going to be a number of people who recover. Now, if we let people go in and out of the room, we'd have more terms in this system of equations. You get it? So we can solve the system, and we can plot over time. But, oh, did you see colors? When I start close up, I can't see colors. What is it? Is this recovered? Right? Infected? So we don't start out with anybody infected, maybe one person. But then a lot get infected. Some of them start recovering, so the rate of infection goes down. And in the end, nobody's susceptible. Okay? So there's your differential equations applied to a very useful model. Now, what happens is some of these terms, these betas, S, and I's, are values that the mathematician, or they have to take data to determine what some of those numbers are. Okay. I have been working at ENSCO for 17 years. I work with chemists. I work with meteorologists. And for 17 years, I have been solving chemical kinetic equations I'm really tired of it. But chemistry, where you have the atoms coming together and they make the molecules. We all live near the Space Center, and fortunately we haven't seen a rocket blow up in a long time. It was about 17 years ago, a rocket blew up. It was a Delta. It was sitting on the pad and it went up. It just cleared the pad and it exploded. I know it was 17 years ago because I had just moved here. And I remember driving going, what's that cloud? You know, the cloud that you'll eventually see? Boy, did that cloud have color in it. Because of what? The SRBs, all the stuff that's in the rocket, kind of nasty. And I had a friend, a little boy who was in elementary school, and he said, they made us come in from recess when the cloud came over Melbourne. There's chemistry going on in that cloud. And it may start out toxic, but maybe 10 miles downriver, it's not toxic because there's chemistry, correct? So differential equations are used to model chemical reactions. And so this is a type of problem that I would work on where I had some chemical that at some rate turned into two other chemicals, and I want to find out how much of the original chemical, the bad stuff, I have. Well, over time, I can model it and find out I don't have a lot of stuff 10 miles downriver. I certainly don't want to be near the launch pad, right? So chemistry is a big area for mathematics. Again, I work with PhD chemists, and they're very good mathematicians. Okay, I'll show you a little bit about ENSCO, and I'll just go to their website because it's much better than my slides. Okay, got it? Okay. So ENSCO is a company up the road across from Home Depot. And ENSCO actually, there's about 600 employees across the United States. Our office up the road is probably 60, 70 people. Okay. ENSCO as a whole does a lot of different things. You can see business areas here. There's a lot of money in railroads. I don't work on railroads. But what I do work on, I'll show you, is called CBRN Solutions. What is CBRN? CBRN stands for, is it there? I was just looking for it. Yes, chemical, biological, radiological nukes. Okay. One of the things I do is atmospheric chemistry and biology modeling. So I talked about the rocket blows up on the pad. The winds are going to push that cloud. Let's say you're sitting in Iraq and something goes off and travels downwind. Do you want the soldiers in the way? You don't want it going over their heads, whatever it is. So what we do is model where are the winds, what type of chemical is it, where is it going, where do you get the troops out of the way, and where do you put the sensors that say, I smell something, I've got some anomaly here. So the mathematician has to work with the meteorologist to determine where are the winds. We have to work with the chemist to decide what kind of chemical is it and what can it turn into. Is it safe? Is it a good chemical or a bad chemical? Okay. So there's a lot of different disciplines, as you can see, that go into solving these types of problems. Okay. Okay, so back to slide. Shift 5? Shift F5. Shift F5. Okay, so that was the ENSCO, what we do there. Some of the other things I've done at ENSCO, I've mentioned chemical kinetics. Sensitivity analysis is some interesting math where if you have a process, I don't know, we had a chemist once who was talking about making lipstick. You can make lipstick, but can you make 100,000 of them in a factory in Arizona when it's 100 degrees outside? You don't want the lipstick to melt. So one of the things lipstick might be sensitive is to the temperature, right? You want to know how sensitive that lipstick is to the temperature. If I go from 50 degrees to 51 degrees, lipstick might not melt. But if I go from 60 to 62, it might melt. So you have to find the one parameter in your whole process that makes it all fall apart. And that's called sensitivity analysis. And again, it's some interesting math, and I've done a lot of work there. High performance computers are the following. We all have PCs on our desk, but there's about 5 or 6 computers around the United States that the military owns, and they're called high-performance computers. So if I have a math model, like if I'm going to predict a hurricane, and I don't do hurricane modeling, but if I did, that model might take 3 days to run. And we don't have 3 days here in Florida, do we? So if you stick that computer program on one of these machines, it'll run very quickly. Not a lot of people have access to these machines, and you have to get special permission and the whole thing to work on these machines. No different than working on your PC. As a matter of fact, on my PC, I log into these machines, and I run my models remotely. Okay. Immune building, I'll mention. I learned a lot about heating air conditioning systems. If we put smoke on the other side of the building, it would come through the vents eventually, correct? We have to track that using some numerical models. So we were tracking, that something was released and it came through the building. And we did this project and it was very nice. And then we were done with it. Well, part of the model I built went into a model that was used at the Salt Lake City Olympics. They had the dormitory where the athletes were living, and they wanted to protect the athletes. So they ran this model with that air conditioning system to see how they could best protect the athletes that were living there. Okay. I'll just mention one more. Spam detectors. If you ever take statistics, and if you do a little bit of reading, you'll find out that in your email box you have spam and non-spam. The reason is because there's a piece of software on your machine that does statistics, and it's trying to statistically look at your email and find out, does it contain the word Viagra? If it does, ship it to the email, ship it to the spam box. And it's looking for various combinations of words to either put it in your real mailbox or put it into your spam box. So again, that's some statistics. Okay, I'll just mention, before I was at ENSCO, I was at a oceanographic company in Louisiana, right outside New Orleans. And I worked there for 5 years, and if you ever have the opportunity to work for a small company, do it. You learn a lot. You work your butt off, but you have a good time. I had a great time. And I did a lot of work for pretty much about the first 10 clients up in the corner, a lot of Navy customers. The Navy's obviously in the ocean. They're interested in waves. They're interested in beaches. They're interested if they want to put troops onto the beach, how deep is the water? And one thing that the Navy does very well is it goes out and measures the temperature of the ocean everywhere. That data goes into hurricane models. Okay, so I did a lot of data analysis, and I worked on something called the Navy Surf model. My maiden name is Kennelly. I'm the second author there. So one of my jobs was to create something called the Navy Surf model. So when the Navy wants to understand some beach, they'll bring up the model, they'll type some data in, and then they'll know everything they want to know about this beach around the world, and what wave conditions to expect, what kind of vehicles the Navy should bring into that beach. Is it shallow water? Is it deep water? Okay, so that was some of the stuff I did in that company. Okay, so those are some of the jobs I've had. But these are some of the questions I've been thinking about the last couple of years. I keep thinking, is that all there is to math, chemistry, physics? I'm kind of bored with the sciences. I've decided to figure out where else is math used. And boy, you just open your ears and you hear things. Every time we have a snowstorm, Jetsons can't figure out where to put their planes. Have you ever noticed? They're always down for a week. Where do you put your planes and pilots is what's called an optimization problem. They have to optimize where to put those planes, determine how long they think the storm might last, and get those planes back in action. JetBlue hires mathematicians to answer those questions. Maybe not very good ones, I'm not sure. Again, you just open your ears and you can actually hear the math. So Home Depot and Walmart are really good when it comes to hurricanes. They have a group. Home Depot has a group in Atlanta. They're called Operations Research Analysts. And when the hurricanes are coming, those guys sit down for days at a time and figure out the logistics of how much wood do I have to send to Florida? How many bottles of water do I need to get going? Where do I stage it? It's called an optimization problem. I was interested in how Google works. So I sat down and figured out how Google works. I said, oh, it's statistics. That's not bad. If you know some statistics and if you're interested, you'll figure out how Google does its searches. I mentioned spam filter is another application of statistics. Disney FastPass fascinates me. Part of statistics, part of mathematics is called random processes or stochastic processes. And what FastPass does is what's called a queue. Like, you know, you're standing in line, it's called a queue. Well, they've got a patent on how to make that queue most efficient, and it's called FastPass. They have patents on this, and the guy who holds the patent lives in Winter Park because he's on my list to call. But it's fascinating stuff that has nothing to do with chemistry and biology. I'm just interested in this stuff. So, okay. So currently I teach here, and I'm a PhD student in what's called operations research at FIT. It's a branch of math. And these are some of the things I'm learning about, and as I mentioned, some of the applications thereof. Machine learning, artificial intelligence, it's almost like people say it every day and don't really know what it is. It's just applications of math, believe it or not. Google hires a lot of mathematicians. Tracking methods I'll mention because part of my PhD thesis is going to be about tracking. We were talking, my advisor and I were talking about how quickly they found the Boston bombing suspects. And of course, they pieced together all the videos, right? And they had all these people out in the streets of Boston. How do you find the Boston bombers? And what you do is you get what's called the tracking method. And you look at a picture, and you can use image processing to pick off all the people in the picture. And then you use what's called a tracking algorithm to track each person through time in each frame of these pictures. So we're interested in using tracking to maybe track cells in a petri dish. If you've got cancerous cells and non-cancerous cells, they multiply, they divide. If you can track them, then you can separate them. Okay. So that's what tracking is. It's interesting. Okay, so my path, my beginning. Welcome to Indiana. I was raised near Chicago, which is near Gary. The only thing up there is steel mills and corn. So I grew up in a I didn't grow up in a cornfield. There was a subdivision in the middle of a cornfield because the farmers couldn't grow corn, so we put the subdivision there. And if you don't believe me, this is a current picture of my elementary school surrounded by corn. Right? We've been there, hasn't we? We've been there. So needless to say, I didn't know a lot of mathematicians, scientists. To be honest with you, the expectation in my family was to get married to a guy who worked at the steel mill and settle down and get married in Indiana. There was no discussion of college when I was in high school. Okay. So where did my career, I dare you to do this. Where did your career path start? I wanted a pony. I wanted to be a veterinarian. Have you been there? In 7th grade, we took the aptitude test, and they said I should be a farmer. So I became a very prolific Lego artist. After I figured out that you can build houses or you can build really weird houses, I was hooked. And they didn't have the Frank Lloyd Wright set around when I was a kid. Frank Lloyd Wright is a very famous architect, one of my very favorites. And now they have one of his houses in Lego. I've been to that house. That was on my bucket list. I got to go to that house. But I seriously considered a career as an architect. And I heard you had to go to college for 5 years. And I said, not going. I'm not going to college for 5 years. That's what an 18-year-old said. I've been in college now for 10 years. Okay, so in high school, something happened. 3 Mile Island is a nuclear power plant in Pennsylvania, and it had a leak, and it scared everybody in the United States. And I became very interested in what the heck was radiation. What is nuclear? What's the deal? These guys in the suits look pretty darn scary. So in high school, I started reading about what is nuclear? What is all this stuff? So I got interested in physics. Einstein, I was fascinated. But I still had no thoughts of college until in high school, the guidance counselors say, hey, you can get out of class and come watch such and such university give a presentation. Have you guys done that in high school? You know, Purdue University came and said, we'll give you an intro of our college. Come to our seminar. Well, I found this college in Indiana called Indiana State. And between my sophomore and junior year, I convinced my parents to send me to college for 2 weeks to try it out. And I enrolled in a class called Electronics and Computer Technology. So we were there for 2 weeks. I was there, you know, without mom and dad, with a bunch of new friends, and I had a blast. We ordered something called Domino's Pizza every night, which I'd never had. We made popcorn every night. We lived in something called the dorm. I mean, it was all totally new to me, and I loved it. So I ended up getting a scholarship. They asked me, well, would you come to college here if we gave you money? And I'm like, yeah, sure. So I went to Indiana State, which is in Terre Haute, and I studied physics. I chose physics because I really didn't have any other ideas. I liked math. I wasn't great at it. I figured, and I know physics, you have to take a lot of math. And I'm like, well, I can do that. So I majored in physics. I was very interested in radiation physics or anything nuclear. Okay. Obviously, you see Einstein up there. The other guy is Richard Feynman, who was one of my heroes way back then. He was one of the fathers of the nuclear bomb out in Los Alamos. So that's why his picture is there. When I was graduating in physics, I didn't know what to do with my life. I certainly didn't have a job lined up. And one of the teachers said, well, you should go to grad school. I'm like, what's grad school? I have no idea what grad school was. And so we talked about it. And long story short is I ended up in Chicago at a place called Rush University Medical School. My mom is a nurse, and there was some subtle pressure in my family to have a doctor in the family. And I didn't want to be a doctor. I didn't want to be a nurse. But I found kind of a compromise. Medical physics is really, you do your CAT scans and your MRIs and your X-rays, all that stuff. But you can do research, like on the brain, building new instruments to image the brain. And I thought, well, that sounds kind of interesting. I'm going to go check this out. So I went to college at Rush for almost a year, and I hated it. I just felt like I was lost. The only people in my class was a guy who didn't speak. There was a Russian who didn't speak English, and 2 Chinese guys who never talked to me. And I was just sad, and I was lonely. I went to the library, and I said, well, I'm going to quit, but I'm going to sit in the library and think about what I want to do. And I thought, what makes me happy? And I went to the shelf, and I said, I want to read a book on differential equations. I was in a medical school, and there were no books on differential equations. And I knew at that moment I wanted to study math, and I didn't want to be at Rush anymore. So I was about 21, 22 years old when I finally figured out what my career path would be. So my grandparents lived here in Palm Bay, and I ended up at FIT. I got in the math department, and let's see. I got in the math department. I studied applied math because I wanted to get a job. I didn't want to teach. I just wanted to get a job and start exploring science with applied math. So it took me a couple years. I worked part-time as I was in grad school. Now, I'll mention along the way of both undergrad and grad, I want to mention a couple of very important things. In my family, God bless my parents, I'm one of 6 kids. Mom and Dad weren't going to pay for college for 6 kids. We paid our own way or we got scholarships, and that's how I went to school. I had a lot of student loans as an undergraduate at Rush University and at FIT, and I'm very proud to say I paid them all off, $280 a month for 10 years. Okay, so it can be done, and I'm grateful for every dime of it. And I think if you're not paying for your education, I have a lot of respect for people who pay their education and work. I started having anxiety attacks in graduate school because I wasn't doing well, and I didn't have mom and dad to go home to. I didn't want to go home to mom and dad. I wanted my career. I wanted to stay at FIT, but I was having anxiety, and I finally calmed myself down enough where I could study. But I wasn't a very good grad student, but I was very dedicated. I know what I wanted. I certainly had self-doubt. I'm the dumbest in the class. I'll tell you how dumb I was. I didn't know there was something called graduate student assistantships where they pay you to go to grad school. And the only reason I found out was because this girl who wasn't as smart as me had one. And I thought, I can do that. So the other thing I'll say is when I was in grad school, I had a life outside of grad school. I hooked up with some new friends who taught me how to row and go sailing, and I had a blast outside of grad school. So I think it's a great idea to have balance in your life, not just school. Okay, so I've got a couple slides if you're interested in being a mathematician. I love Spock. And the reason I like Spock is because mathematicians are very focused and very logical. And it comes at a price. I can turn my emotions off and be totally focused and logical. And it's a bad thing when you have a family and students, and I have to watch that. But you definitely need to be logical as a mathematician. No matter what you do, you need talent and interest, whether it's being math or anything else. Mathematicians, it's true, we look for patterns and relationships in data, and that helps us find models. Believe it or not, I think back to my Lego days. A lot of pattern in Lego. I was very interested in that. Communicate clearly is something, when I'm trying to hire someone, I want to know how good their communication skills is. Can they write? Can they write sentences with verbs? I can't tell you how many people I've worked with. I have to rewrite everything they write because they can't communicate effectively. Let's see, little supervision, you have to be able to work on your own. Half glass empty. I swear to God, I get in trouble every time when someone says, are you a half glass full or empty type person? Have you heard that question before? Are you optimist or pessimist? And I'm proud to say I'm a pessimist. I'm half glass empty because mathematicians are always looking for what's going to make that model fall apart. Where is the bug in my computer program? That's where that comes from. I'm not going to be the yes girl. I'm always looking for the holes in the algorithm. If you're going to study computational math, you really need to be able to program. And I encourage everyone taking any science is to learn one computer programming language. And again, I learned a couple, and every once in a while you get confused between the two. Which one am I programming in today? But you definitely need to program. And in my job, I've always been the type of person that can analyze a problem, figure out what I need to do A to Z, and implement it. Or else hand it off to someone who can do those steps. But you have to envision the whole thing A to Z. I think I have 3 more slides. I have a son, my son Christopher, and a husband, and juggling. Yes, I rely on my husband, I rely on friends. I don't have any family in town, but I'm a firm believer in smart women ask for help. That's my quote for my lifetime. Smart women ask for help. Dumb women just suffer, okay? And you hate to read about those dumb women in the newspaper who have done something stupid because they didn't ask for help, okay? I learned a long time ago when you ask for help, people will give it to you, you make new friends, you help them, it's great. And that's hard coming from a woman who I was a single independent woman for a long time. So asking for help is not in my nature, but I'm glad I've done it, especially when you have kids. And when you're juggling a lot, nothing's perfect. I don't get all my homework done to the best ability that I really want. My son plays too many video games. We're not going to go there. Okay. I can do a lot in 5 minutes. When my son is in the shower, I sometimes have a book in my hand that I'm reading because I need to get something done. I can focus for 5 minutes and make something happen. I don't suffer with the guilty mom complex. I don't even listen to stories about supermom. I could care less. And I constantly think about, what do I want to do in 10 years? You know, do I want to be just teaching? Do I want to be just a mom? Do I want to just be solving chemistry equations? No, no, and no. So I'm always thinking ahead. I've learned a lot as a woman in the office. I'm a good listener, and I've read some good books. Talking 9 to 5 is a mandatory book for women in the office. You learn a lot from the author, Deborah Tannen. Judge Judy is a blast. Judge Judy wrote this book, Beauty Fades, Dumb is Forever. It's really good. She's a very logical, sharp woman. Don't be afraid to say, I don't know in the office. And I play this game in the office. After the meeting, I'll say, I have no idea what you said. And you know what? All the men in the office suddenly stand up and say, oh, I didn't understand it either. But they won't admit it. I have one friend in the office who apologizes for everything. I'm sorry I'm 5 minutes late. I'm sorry I didn't get this done. It's like, just quit apologizing and go through your day. It's tiring. I've heard about this disease to please. Women like to please. You have to learn to use the word no, or otherwise you're going to be trying to satisfy everyone and not get anything for yourself. So I've learned that. And I think this is my last slide. So my advice to anyone, women, anybody entering the STEM field, do what interests you. Otherwise, you're not going to be happy. You're going to be a miserable person. If you're going to study a science or study math, study a science with it so you can apply that math to the science. I'm sorry, I'm saying too much. I fall into the trap of, I'm the dumbest one in the room. I'm not smart today. And it's hard. I have problems with self-confidence. I think we all do. But you're not. If you give yourself a shot, I promise you won't be the dumbest one in the room. The dumbest one in the room is the one who gives up, doesn't even try. I like to work with people who are supportive instead of the person in the room who's very negative. I want to work with someone who wants to go to the end of the problem instead of someone who just sits there and says, I don't know what to do. I give up. And there's going to be times of self-doubt, but you've got to figure out if you're going to go down that road or flip and say, okay, I had my self-doubt. I'm going to try again. Okay. And I say the end question mark because I just started teaching here. I still work at ENSCO. This isn't the end. I'm still looking at a future career. So that's what I have here. Thank you. Questions? It doesn't. Some people say engineering science company, but it doesn't. Yeah.
Any questions?
So,
Yeah.
why do you think Google bought up all of the robotic companies?
I heard that, and I'm figuring that out for myself. Because part of the tracking algorithms I develop are part of the robot. I don't know yet. I heard it today. Yeah.
How often did Intel call you with their big problems?
They haven't, but when we go to parties, when I still see them at the parties, like, oh yeah, maybe we can call you about this. And I'm like, yeah. This is my son. Yeah.
What made you change your career?
I think two reasons. I've always wanted to teach. In my brain, when I'm doing work, I'm teaching. It's just strange. I still like to do other projects, but I've always wanted to teach. And at some point in my career, I said, I'm going to teach. But I'm still not going to give up on other things that interest me. It won't, yeah.
What do you teach here?
I'm currently teaching intermediate algebra and statistics.
All right. Thank you very much.